sure, just because I get second derivative equal to 0 doesn't guarantee it's a what? Point of inflection,
So,
right? Does that make sense?
now can I ask a question? So,
Sure.
can I conclude from this that if a function is even, so that's going to be concave up, and if a function is odd, that's going to be concave down. But a function that can neither be even or odd, like this one, that could have a point of inflection.
That's pretty good. That's pretty good. And can you, that's pretty darn good. And I'm trying to think of, here's some other neat even functions. How about this guy? I gotta match that, make it even, right? I mean, there's an even function, but do you see a lot of points of inflection in there? You can. All right, look, it's concave what? Concave down, then it went what? Concave up, then it went concave down, then it went concave up, then it went concave down. He's hitting on this even functions and odd functions. That was good, Art.
Thank you.
Very good. All right, here's my next one. Rowan, hey, I know you might need time to write outside. I got it easy. I just get to erase all these. All right. All right. All right. All right. X cube's too small. We gotta do x to the fourth.
Give an odd function. Is that going to, that looks like an even function, right?
Yeah, you're right. That's even.
Yeah, that's an odd function or something.
We can do an odd one next one.
Okay.
Yeah. You bet, Art. We should just make one up too.
All right.
Or we can do a sine trig function.
That's fine. Yeah.
All right. What test do we have to start with first? What do you get?
4x cubed minus 16x.
What do we set equal to?
0.
That one right now. All those factoring skills are coming into play, right? Josephine, I have to mention, likes to graph the first derivative. And she'll check the x-intercepts, okay? So if you're like, that's so great with factoring, you can use that tool to help support you in that manner. But, Sarah, can I just factor anything out of a 4 and a 16? 4?
X.
And the x too, right?
Yeah.
But that, I knew you knew that. You hit the 4, perfect. What are we left with this time?
X squared minus 16.
X squared minus
With 4 minus 4, sorry.
Well, good job. That is. Isn't that a difference of perfect squares?
Mhm.
Sometimes you get trinomials, sometimes you get these difference of perfect squares. Worst case, Claire, is when you get, you go, oh, I can't factor, now I gotta do quadratic formula. I know, we're like, sometimes that happens. But you can use your grapher. Doesn't mean you'll be alright, just getting what those numbers are, you know? That happens. Alright, I'm gonna keep factoring. 4x, leave it. X plus 2, x minus 2. How many critical points this time?
3, 3.
3. You go, I thought you said you ignore the 4. We do. We don't really care about what we're talking about, that x there. Yep, Sarah outstanding. She said it has an x. I want to be aware of that x out there. So let's see. What makes 4x equal 0?
0.
0. Alright. Critical point. That's a CP. Critical point. What makes x plus 2 equal 0? Some of you don't have to do as much writing as me. That's okay. I just like to show what we're doing. We're finding these critical points. Alright, negative 2. And then what makes x minus 2 equal 0? There are 3 critical points. Alright. I can start filling things in. Not yet. I have to do something called the first derivative test. I make a number line, right? Alright. You just make a number line. Now list from lowest to highest. What's the lowest number in there?
Negative 2.
It goes back to your point, Josephine. Lowest to highest, left to right. We describe everything from left to right. I gotta do this left to right, numerically. Alright, we got a bunch of test points to plug in here. But it's probably, not guaranteed, but it's probably gonna do what? The signs. they're probably gonna alternate, right?
Mhm.
Everyone agree? Right, we expect that. Cool? They're probably gonna like plus, minus, but we'll see. Doesn't matter where you start. You wanna use -3?
Okay,
Alright, I like this one. So I mean negative
so that's
times a negative
negative, positive,
times a negative. Do you agree?
yeah, that's
So everyone,
negative.
if I plug a -2 here, this is the one I like. You might like that one, I like this one. -3, that would be negative. -2 plus 2, that would be negative. -3 in here would be a negative. What's a negative times a negative times a negative?
Negative,
I don't care about the number, I'm just looking at the sign, right? Always remember that. I just care about the sign, alright. Between -2 and 0, an easy one.
-1,
-1 work?
mm-hmm,
4 times -1, negative.
negative,
-1 plus 2,
positive,
positive. -1 minus 2, negative. So listen, what's a negative times a positive times a negative?
positive,
You all agree? A negative times a positive, you get 2 negatives. Just like we thought, it's starting to what?
flipping,
Starting to flip. I mean, can you what do you think this is gonna do? I
negative,
mean, so we think, we're like, it's probably gonna do it. I know it's not guaranteed, but it's probably gonna go minus here, it's probably gonna go plus here. Why? Because we see it's a polynomial. Polynomials do that stuff. We don't see any square roots in there, absolute values, or things of that sort. Cool. Alright. I plug in 1, positive, positive, but negative. I plug in 3, positive, positive, positive. This is F prime. Now I say we make a rough sketch of this. Of F, no, of F. Don't you make a rough sketch of F? Yeah?
mm-hmm,
Just rough sketch of F. Alright, let's see, what would F do? It would what? What's that mean? It went down, then what?
yeah,
Right? Right, very good, and goes up, go on, then what? Oh, then goes down, then what? And when we do x to the 4th graphs sometimes look like this thing? Like the debit, yeah, you bet. It's probably got a little. In the end, we'll sketch a nice picture. Get all this stuff out of the way. Alright, let's fill in all the blanks. Now look at all that stuff. Let's crush it. Increasing. Look for the pluses. -2 to 0, where else? Alright, how about decreasing? -3 and -2, anywhere else? Can anyone read that? Harshman, is that okay? Yeah, okay. I know I got the writing from before, when I'm writing over there, I didn't want to make sure it didn't get mixed with the other writing. That's an infinitive. I keep everything open parentheses. These are intervals. Now, you might use this to help you out. Where's the local max, or are there 2 of them?
there are 2, no, 1, sorry, at 0,
So there's one local max, you're saying it's at
0,
0. I'll fill this in a second, because that's key, we gotta know where to plug that. How about local min? Ooh, there's 2, so I gotta put an extra space here on, that's okay. Then we got 2. We got a couple local mins. True? I have a sense they're probably gonna take on the same y value though, right? It's an even function, right?
mm-hmm.
You know
Oh,
this.
so that's gonna be,
That even odd function does help out sometimes. Just because it's even, it means it's so reflective. So you're like, oh yeah, they're gonna take on the same, these are gonna take on the same y values. Alright, at 0 is local max, and where are the local mins? -2 and what?
2,
Now, can you remember this? Where do I plug these now? Gosh, you're good. Seriously, very good. This is where, because it says at x equal to their local max is, and you're like, I'm going to the original, the actual original, like this was a temperature function. What's the temperature? You know, it's like I'm gonna put that actual temperature down. The local max is, oh I love plugging in zeros, that's easy, 12. Why did I use 0? Oh, look at this. We know there's a local max, couple ways. One is the plus to the minus. That would mean the function did this. Look, I'll use my hand. It went up, increasing, then went down. And Josephine, I think just to remember that, I'll be honest, Josephine, some students just memorize plus to minus as max. I don't recommend it. I would say more conceptual. Think of a function like use your hand if you have to, or make a sketch. Be like, it went up, it goes, we describe everything left to right. Left to right, it would do that. All right, hey, and when you want to use your calculator, plug in those twos or do it in your head, I don't care.
-4.
-4 on both of them? Hey, can we already make a rough sketch of this graph then? We'll do second derivative, but can we?
Yeah.
All right, ready? Rough sketch. All right, we got to get rid of -2, and we got to get rid of what?
Positive 2.
All right, and -2 got to a what? -4. And 2 got to a -4. Whoop, whoop, whoop. What's it going on at 0?
0.
Is it up at 12? And what's this graph do? Odd or even function, everyone? Even Steven, do you agree? That's an even function. Sure? Even Steve. That thing's even. Except my drawing's not that great. Sorry for my sloppy work. But it's even, right? Alright, cool. Hey, now let's get this done. Can I erase? I erase everything but the first derivative because I need first derivative to get the second derivative. What determines points of inflection and concave up and concave down? Oh, second derivative. So let me write it again. F prime was 4x cubed minus 16x. Give it a shot, everyone.
12x.
Square.
Awesome. 12x squared, and is there anything else?
Minus.
Minus 16. I think we're going to get a fraction out of that. Alright, let's just see. This is going to be interesting when I want to know how you want to solve this. Claire, I wouldn't use quadratic formula there.
No.
Take out 4.
I wouldn't use quadratic formula on that, would you? No. We got easier ways. We know easier ways, but we're trying to solve for x equal to 0, right? Excuse me, this function set equal to, this portion is set equal to 0. We're trying to solve for x. So, I don't know, Kayla, I guess this would be one way. I could add 16 on both sides. Right? You would say, because a lot of you solve these this way.
Can we not factor or no?
You could, but you'd have to be careful. That's really a difference of squares. But you'd have to know what to put in that coefficient to the x of each one. Cool, I'll show you that in a second. If you want to see that, it'd be a difference of squares in terms of factoring. Okay? Now, this is one way. Now what could I divide on both sides? And Kel, I'll show you that in case you prefer to. Can I reduce it?
Yeah, 4/3.
Yeah, when x squared equals 4/3. Kayla, what can I do to both sides now? Take the old
Square.
square root. Now don't forget, there's something called the square root property. If you square root both sides of an equation, you gotta put a what?
Plus minus.
Plus or minus down. So maybe there's 2 points of inflection over here, because that would give us 2 possible points. Do you see 2 possible points of inflection in there? Right. Okay, that's what I mean. So it helps you catch this law. Don't forget the plus or minus. So x equals plus or minus. All right, that's one way to write it. I think we can improve that though, because a lot of you know the square root of 4.
2.
So are you okay if I leave this top numerator just a 2? I'll leave the bottom goofy. Now if you like rationalizing the denominator, go right ahead. That would be plus or minus 2 squared roots of 3/3, right? But that's okay. This is way better than that though. And you got a nice neat 2 up there. Now these aren't points of inflection, but these are called
Possible.
possible. Maybe they are. How do we make sure, or how do we know it's certain that they're points out? We're going to check to see the concavity changes. So what test do we do? Second derivative test. All right. negative 2 over square root of 3, and 2 over square root of 3. Now, where am I plugging these? If it's a second order test, where am I testing these? I test them in the second derivative. What's this going to tell me about? Concavity. Okay? So here, if you want, if I'm not, you might want to rewrite the second derivative equation right here before we forget. So you plug it in the right equation. What is the second derivative? It's that thing. Cool. Alright. Who's got an easy test point in here?
0.
12 times 0 squared minus 16? Someone else, Daniel. That's a goofy looking number. You want to just use like 5?
2.
Yeah, 10. They were like, what the hell? Just pick a big number. 100. And when it's 12 times 100 squared minus 16 positive.
Positive.
I mean, sometimes it's okay to just pick 1,000. You're like, yeah, 12 times 1,000 squared minus 16 will be positive. Do you agree?
Mm-hmm.
And what do you think?
That's positive too.
Keeps alternating. All right, so how many times did the concavity change?
Twice.
So how many poise we got?
2.
You want to just write it like this? Plus or minus? Okay. Remember, I said just listen. I'm okay, just listen to the x values. Unless you want to plug it back in there and write them as xy coordinates.
Yeah.
Ordered pairs. Web assign will make you do that. I just say listen to x values. Now, all the hard work's done, everyone. Where's it concave up?
So,
Right there. From negative infinity to
2.
anywhere else? Oh, so what should I put between them?
Union. And 2 root 3 to infinity.
Yeah, and where's it concave down?
Negative 2 root 3 to 2 root 3.
Negative 2 over root 3 to